how is health risk assessment CNN works? How our health risk assessment, if we talk about health risk assessment, then how our convolutional neural network works there. Our convolutional neural network, it processes the data with a grid topology approach that we've just seen, that whenever a particular image it is being inputted into CNN, it is categorized into a grid topology, which is a set of spatial correlation between various data points. In the case of images, the grid is usually two-dimensional. If you are talking about time series textual data, then our grid is one-dimensional. That means, first of all, the first step that we have to do, if we want to understand that how the health risk assessment of CNN works, the first one will be CNN will process the data with the grid topology approach. The convolutional algorithm, it is applied to recognize some aspects of the input. It will take into consideration the variations of an input to determine the sparse interaction between variables. Whatever variables we have created, it will determine the sparse interaction between them. To apply the same settings for many functions of the model. This CNN, it works on the principle of parameter sharing also. That means the same settings can be applied for many functions into our model. So how does it work? First of all, CNN processes the data with a grid topology approach. Grid topology approach, that means what is it doing? A set of spatial correlation between the data points, the various data points in the images, it will be created. Usually in the case of images, this grid is two-dimensional. If you're talking about that textual data, this grid is going to be one-dimensional. Then the convolutional algorithm will be applied to recognize some important aspects of the input, to take into consideration the variations of the input. Whatever input is being provided, what all variations can it generate? To determine the sparse interaction between the variables. If you have different variables, how to provide the sparse interaction between them? It has to be determined. So that is how it works. To apply the same settings for many functions of a model. If we have many functions in our model, so the same settings can be applied into them. Then we will talk about one important topic, that in our convolutional network, we have a convolutional layer, which is very important. So from where has it received the motivation? If we talk about convolutional neural network, there is a convolutional layer in that. From where has it got the motivation? Basically, convolution leverages three important ideas that motivated computer vision researchers. First is the sparse interaction, second is parameter sharing, and third is EQ variant representation. So these are the three main important things which, with the help of which, or we can say what is the motivation behind our convolutional layer. We will understand about them one by one. First of all, we should know that natural image, it has two main characteristics. First is locality. Now, what is locality? Locality means nearby pixels are more strongly connected. How we can understand it with the help of example. Like if a image of a person is being shown on our CNN, if the hair of that person is coming, so if one pixel is black colored there, another pixel may also be black. Next pixel may also be black. This is called locality. That means nearby pixels, they are more strongly correlated. So this is called locality. Second is translation invariance. That means meaningful patterns, it can occur anywhere in the image. If we talk about translation invariance, that means meaningful patterns, they can occur anywhere in our image. Tribal neural network, they use matrix multiplication by a matrix of parameter. describing the interaction between the input and the output unit. This means that every output unit interacts with every input unit. This used to happen in the earlier neural network. That means every output unit will interact with every input unit. But convolutional neural network, they have sparse interaction. How does it achieve this sparse interaction? This is achieved by making the kernel smaller than the input. Example, an image can have millions or thousands of pixels, but while processing it using the kernel, we can detect meaningful information that is of tens or hundreds of pixels. So, there where we are applying this convolutional network, we are applying the application of sparse interaction. How is it achieved? It is achieved by making our kernel smaller than the input. Example, our image, it can have millions of pixels, but when we are processing it, we can detect meaningful information because all these pixels may not be of equal importance. Some pixels may be blank in an image, some pixel may be background which is not very important for that image. So we can detect meaningful information which is normally of tens or hundreds of pixels.